Hello everyone, this is Mr. McMillan, and I'm here with the instructional video on the last thing we're covering on polygons, which will be tessellations. Okay, so in art class you may have talked about what a tessellation was, but if you didn't, a tessellation is defined as a covering of a surface with a pattern of flat shapes so that there are no overlaps or gaps. No overlaps or gaps. Tessellations can be made of a variety of shapes, placed edge to edge, or using a single regular type of polygon. So regardless of what you look at here, any shape can form a tessellation, but they can't form it with every shape. And that's because some of them have overlaps and gaps, okay? So they have to fit neatly edge to edge, okay? So our regular tessellation, there are two types. There's a regular tessellation and an irregular. And a regular tessellation is those that form a pattern by repeating a regular polygon. So regular tessellations form by repeating a regular polygon. Okay? So if you remember, regular polygons are those that have all of the angles being congruent and all of the sides being congruent. And what we're going to focus in on is all of those angles being congruent, okay? Now, of all the polygons that exist, only 3 polygons form regular tessellations, only 3 of them. And as we work through these examples, we're going to take note of the interior angles and the sum of the angles around each vertex. So in our first one, this first regular tessellation, what shape do we have here? Well, as we can see, we have 6 shapes around this vertex, and every single one of them are triangles. So regular triangles can form a regular tessellation. So a 3-sided regular polygon can tessellate the plane. So let's look at the vertices. Now we have to determine these interior angles to determine the sum of the angles around the vertex. So what we're looking for is one individual interior angle here, okay? So remember that your formula to do that is to take the sum of the interior and divide by the number of sides. And your sum of the interior is given by the formula n minus 2 times 180 divided by n. Now for a triangle, n equals 3. So we're going to plug 3 in here. So we get 3 minus 2 times 180 all over 3. 3 minus 2 is 1. 1 times 180 gives you 180. And it's still divided by 3. So 180 divided by 3 gives us 60 degrees for the interior angle. Now, since all of these are the same equilateral triangle, same regular triangle, each one of these angles next to this vertex would be 60 degrees. And that's true for any of those vertices. 60, 60, 60, and here's 60, 60, 60, 60, and 60. And so now what we want to look at is determine the sum of the angles around each vertex. Well, the sum of the angles would be you adding them all together. So you would take 60 and add it together 5 more times. Or you can take 60, there's 6 of them, so 60 times 6, which gives you 360 degrees. So in this one, the sum is 360 degrees. Okay? All right, next up, as we can tell from our second tessellation here. Our second tessellation deals with four-sided figures. Now, you'll know these as squares, right? But the generic name for them is a quadrilateral, where n is equal to 4. So a quadrilateral, which of course is just for a regular quadrilateral, is just a square. We can use the formula to determine the interior angles, but since these are squares, we know these have to be 90. Okay. Now I will show you that if you do your formula here, you'll end up getting 90. So you get 4 minus 2 times 180 divided by 4. 4 minus 2 is 2 times 180 is 360. 360 divided by 4 gives you 90. So one interior angle is 90 degrees. And all of these would be 90 because all of the angles have to be the same. Now, if you look at that and you take the sum around the vertex, the sum of the angles around each vertex, sum equals 90 times 4, which is 360. So far it looks like the sum of the angles around each vertex is going to be 360. So let's see if that holds true. So let's look at the next shape. What type of shape does this tessellate with? So we have 1, 2, 3, 4, 5, 6 sides. And a 6-sided figure is called a hexagon. So the only 3 regular polygons that tessellate are triangles, quadrilaterals, and hexagons. Now we're going to do the same thing here. We're going to find the interior angle and then figure out what our sum is. So the interior angle is n minus 2 times 180 divided by n. So we get 6 minus 2 times 180 all over 6. 6 minus 2 is 4 times 180 divided by 6. 4 times 180 is 720 divided by 6, which is 120 degrees. So all of your interior angles here are going to be 120 degrees. And let's find the sum. So we have 120 plus 120 plus 120. So 120 times 3, which again gives us 360 degrees. Now the reason that this works the way it does, and the reason only these can tessellate the plane, is because they're the only ones with interior angles that are evenly divisible or evenly divide 360. Okay, 60 evenly divides 360, 90 evenly divides 360, and 120 evenly divides 360. So that's why a triangle, quadrilateral, and hexagon are the only regular shapes that can tessellate the plane. However, regardless of the shapes that are tessellating in the plane, it can be a combination. The sum around the vertex or corner point of a tessellation is always 360 degrees. Always. And this is because if you look at this, you can basically draw a circle around that vertex. And the degree value of a circle is 360. All right. So let's look at some examples here. So number 1, it says the figure below contains a regular hexagon and an isosceles trapezoid. What is the value of x? Now this only has 2 shapes in it and it's not a pattern like we've seen before, but we can see they meet at that vertex and they don't overlap. They meet edge to edge perfectly. So we know we're dealing with a tessellation here. So to figure out what x is, we first need to figure out what these two angles are. Well, we're going to start with the easier one, which is the hexagon. Okay, so the hexagon, it's a regular hexagon, so n equals 6. And you can find the one interior angle by doing 6 minus 2 times 180 divided by 6. Remember, n minus 2 times 180 over n. So this gives you 4 times 180 over 6, which is 720 over 6, which is 120. So we know that angle is 120. Now, this next one is an isosceles trapezoid. And we haven't talked about isosceles trapezoids yet. That will come in a couple lessons. But an isosceles trapezoid has the property that you have two angles congruent to one another on the bottom base and two angles congruent on the top base. So a trapezoid is a quadrilateral. And if we find the sum of the quadrilateral, we get 4 minus 2 times 180, which is 360. Okay, that's our sum. So we know that all of these angles, all four of these angles have to add up to 360. Now we only know the 247s. So if we take 360, and since we already know these and these have to add up to 360, we need to take these away from 360. So we're going to subtract 47 2 times, and that gives us 266. Now, obviously 266 is too big for just one of those angles. So what we need to do there, we know they're congruent, so we need to take that 266 and divide by 2. And so that gives us 133 degrees for our missing side there. The other way you could have done that, you know these two are supplementary, so you subtract them from 180. Either way works. Well, now we have those two angles we were missing, and we know the sum around the vertex is equal to 360. So that means that x has to equal 360, take away those two angles. So 360 minus 133 minus 120. And if you do that in your calculator, you get 107 degrees, or 107 is x. And that's the gist for all of these. For any tessellation problem, really, is that you're looking for the missing angles that you don't have, and then you use them and the fact that the sum of the vertex is always 360 to find what your missing angle is. So let's look at number 2. Number 2 says a regular octagon and a regular decagon are shown below. Find the value of x. So a regular octagon has 8 sides. Remember octopus, 8 legs, 8 sides. And a regular decagon, and a decagon has 10 sides. Remember decade, are shown below. Find the value of x. So we need to find these two interior angles before we can find x. So let's do that. So the octagon, our interior angle, you do n minus 2 times 180. So on the top you do 8 minus 2 times 180. And then on the bottom you do n, which in this case is 8. So you do 8 minus 2, which is 6, times 180 over 8. 6 times 180 is 1080. Divide by 8, excuse me. And when you take 1080 and divide by 8, you get 135. So that's the interior angle for the octagon. Now let's look at the decagon. So the decagon, we're going to do the same thing, but this time instead of n being equal to 8, n is equal to 10. So the interior, we have 10 minus 2 times 180 over 10. 10 minus 2 is 8. 8 times 180, I believe, gives you 1440. Yep. 1440 over 10. And if you take 1440 and divide it by 10, you get 144 degrees. So 144. And now you know the sum of around the vertex is 360. So to find x, you take 360, subtract 135 and 144. And when you do that, 360 minus 135 minus 144 gives you 81 degrees. So x is equal to 81. All right. And those were the examples that we covered in class. I'm going to add a couple of examples here on the end of it, just to show you how these worked out. I did give the answers out in class, but I want to make sure you understand how to do that. They look a bit different, but it's exactly the same process. So the figure below is composed of the regular decagon and triangle shown. What is the measure of angle ABC? Now, we have a decagon and a triangle. So ABC is right here. It's that angle right there where B is, okay? So it's the same process, it just looks a little bit different. Instead of an X, it has ABC there instead. We're still looking for the same thing. So for the decagon, we have to find our interior angle. And the interior angle is 10 minus 2 times 180 divided by 10, which gives you 8 times 180 over 10. And when you do that, you get 144 degrees, just like we found up here. Okay. Now we have to find it for the triangle. So your triangle, let me write in the 144 here. Then your triangle, you have n is 3, so you do 3 minus 2 times 180 divided by n, which is 3. So 3 minus 2 is 1 times 180 over 3. So you get 180 over 3, which is 60. So the triangle here is 60 degrees. All right. So 144 and 60. So we know that the sum around the vertex is 360. So to find the measure of angle ABC, we do the same thing. We take 360 and subtract 144 and 60. And when we do that, we get 156 degrees for the measure of angle ABC. All right. And number 4, the figure below contains a regular pentagon and regular dodecagon. Find the measure of angle X. So we have a pentagon and dodecagon. A pentagon has 5 sides and a dodecagon has 12. So we need to find the interior angle there. So we'll find it for the pentagon first. So your interior angle is n minus 2 times 180 over n. So we get 5 minus 2 times 180 over 5. 5 minus 2 is 3. 3 times 180 is 540. Divided by 5. When you divide 540 by 5, you get 108. Now we need to find our interior angle for the dodecagon. So we do, this time instead of using 5 for n, we use 12. So 12 minus 2 times 180 over 12. 12 minus 2 is 10 times 180 over 12. So we get 1800 divided by 12, which is equal to 150 degrees. So now that we have our two interior angles there, we know the sum around the vertex has to equal 360. So we know that x has to be equal to 360 minus 150 minus 108. And if we take that into our calculator, we get x being 102 degrees. All right, and that's going to do it for this video, guys. This was the last thing we were covering before the quiz. This will not be a very big part of the quiz, but you do need to know how to do a tessellation if you see one. And you also need to know that the only regular polygons that can tessellate the plane are triangles, quadrilaterals, and hexagons. None other work. Pentagons don't work, octagons don't work, decagons, so on and so forth. Okay. So I hope this video helped, guys. If you do have any questions, feel free to contact me or Mr. Thompson. We mostly use the email, but you know, IM chat on the Google works as well. So thanks, guys, and I will see you in the next video.